So the term used in geometry to describe figures with the same shape is similar. In geometry, when we talk about congruent figures are figures that are the exact same size and the exact same shape. Similar figures means they have the same shape, so they could both be triangles, but one is smaller than the other. So this would be an example of similar. And what's happened is that one of them is a dilation of the other one. Dilation means to shrink or enlarge. So if I'm supposed to draw a dilated copy of this triangle, a dilated copy means either a smaller version or a bigger version. So I'm going to draw a smaller version first. It's going to look something like this. Then I'm going to draw a bigger version. And it's going to look something like that. So these three triangles are similar because they're the same shape, but they are different sizes. So dilating a triangle changes the size of the triangle. It changes the size, but does not change its shape. So the size is different, the shape is the same. And similar triangles can be made into congruent triangles by dilating them. So if I have two similar triangles, and I want to make them the same size, I just need to dilate one. That means I need to shrink one or enlarge one. All right, and the symbol for similar it's this little symbol. It's like a tilde. So if we had a triangle, ABC, and let's just say the angles were 40, 60, and 80. And DEF was similar to ABC. What you need to know is that the angle measures are going to be the same. So if they are similar triangles, then they're going to have congruent angles. So similar triangles have congruent angles. Now, same triangles, ABC and DEF, and let's say that AB had sides of 4, 10, and 8, and DEF was twice as big, then that means each of the sides are twice as big. So if the sides are 4, 10, and 8 for ABC, then for DEF, they're going to be 8, 20, and 16. So when you have similar triangles, the ratio of all three pairs of corresponding sides are what we call proportional. So we're going to be studying at proportions, which you will learn about some more in the next lesson. And similar triangles are triangles whose corresponding angles are congruent and whose sides are proportional in length. So if they're similar, the angles are congruent, the angles are the same, the sides are going to be proportional, they're going to be different. So the ratio of any side length to the corresponding side length of the original is called the scale factor. The scale factor tells us whether the triangle is twice as big or 3 times as big or 4 times as big or half the size, whatever it is. So if we want to know what the scale factor is, what we have to do is we take one side and we divide one side of one triangle and divide it by the corresponding side of the other. So looking at these two triangles here, ABC and DEF, I would do 96 over 24. I'm also going to do 100 over 25, because notice 100 and 25 are both in the bottom here, and 96 and 24 are both on my right side. And then I'm going to do 29 over 7. Okay, so my job is to figure out if these are proportional. Well, if they're proportional, when I divide, I should get the same number every time. 29 divided by 6 is 4. 100 divided by 25 is 4, so far I'm good. 29 divided by 7 is going to be 4.14. That's different, so no, they're not proportional. They're not similar. All right, last thing, to find the scale factor, because they're going to ask you to do this. Okay, to find the scale factor, you take a side from the new triangle and you divide it by a side from the old triangle, from the original. To find the scale factor, you do the new triangle divided by the old triangle. So for questions 1 through 7, it says calculate the scale factor of triangle DEF to ABC. So remember that to find scale factor, we're going to take one of our new sides and divide it by our corresponding old side. So for number 1, if I picked 15, and we're going to say the new side is the one on the right. So I could do 15. And then if I picked 15, I have to divide it by 5 because they are corresponding sides. And 15 divided by 5 is 3. So that means that ABC is 3 times as big as DEF. Number 3. If I'm supposed to find the scale factor, I need to pick one of the new sides. So that's the one on the right. And I'm going to pick this time 36. And 36... And then if I do that, I have to pick 9 because that's in the same place. 36 divided by 9 is 4. So ABC is 4 times as big as DEF. Number 5. Number 5 is a little bit more confusing because of the way it's written. It's turned sideways. So I'm still going to pick a side from the new one, which is the one on the right. So I'm going to pick 4. So that's going to go on top. I should have to figure out which side that corresponds to out of the big one. So what I notice is that 4 is my longest side here. So I need to pick the longest side out of the other one, which is 92. So I need to take 4 over 92 and I'm going to reduce it. I would just do, in your calculator, 4 divided by 92, and then hit math, enter, enter. And it's going to reduce it for you, and it's going to tell you that it's 1 over 23. So your scale factor would be 1/23, which means that this particular triangle, ABC, is 1/23 the size of DEF. So for number 7, we have triangle DEF and triangle ABC, and we are, again, dilating, trying to find the scale factor. So I need to pick the new triangle. So I'm going to pick one of the new sides. I'm going to pick 30. And I need to put it over one of the old sides. Well, I've got to figure out which ones go together. So I'm looking at these numbers. I have 24, 30, and 40. 30 is the middle number. So out of the other one, I want the middle number, which would be 45. 30 over 45, when I reduce that, is going to be 2 over 3. So my scale factor is 2/3. For number 9, it says if triangle ABC is similar to triangle DEF, and the scale factor from ABC to triangle DEF is 2/3, what is the length of DF? So for this case, I've actually got the scale factor, and I need to find my other sides, so all I have to do is I have to multiply each side by 2/3. So to find DE, I'm going to do 42 times 2 divided by 3. And when I put that in my calculator, it's going to give me 28. So DE is 28. Then I'm going to go with DF. Well, to find DF, that's the same as side 45. So I'm going to multiply 45 times 2/3, and I'm going to get 30. And then I'm looking for EF, so I'm going to take 39 and multiply that by 2/3, and I'm going to get 26. So my side lengths of DEF are 28, 30, and 26.